All right, we're moving on to Pythagorean theorem and intersecting chords. So for this first one, the key is, after you read through it, that you have a radius and a tangent. Anytime you have a radius and a tangent, they create a right angle where they touch. So that is important to realize. Then if we label the rest of this, so AD is 18, ED is 15, and they're looking for AC at the end of it all, which is right there. Okay, so two places where Pythagorean theorem can come. So the first one is here. But as you can see, this right triangle right now doesn't have much going on. The second thing, if you remember from the last one, is that when you have a diameter and an inscribed angle, you also have a right angle there. Do I have another color? We're gonna go black. Okay, so this is also a right triangle, and I'm just gonna highlight that right triangle to make sure that you can see it. Now this next piece that you need to realize, so we're gonna use Pythagorean theorem. This is what we're looking for. I still don't have my entire hypotenuse of the right triangle. But because this is a radius, I know that all radii in a circle are also going to be the same. So because of that, I now know that this entire distance is 30. So I can do Pythagorean theorem with 18 squared plus x squared, right? Leg squared plus leg squared equals hypotenuse squared. From here, I'm going to do some algebra. So 18 squared is 324. 30 squared should be 900, but I'm double checking it because I am. And then subtract 324 from both sides, and we're at 576. And then we take the square root of both of those sides, and we get 24. So 24 is that final answer in this case. Okay, so again, you have a right triangle here that you can use Pythagorean theorem for, but you also, when you have this tangent, have Pythagorean theorem in this circumstance that I'm scribbling in right now, that right triangle as well. That can also be a right triangle. So two different scenarios. Okay. The next one are where chords intersect. So these are intersecting on the inside of the circle, and they are chords that are crossing. I like to use this rule, part times part equals part times part. This rule comes from similar triangles. So if we really wanted to right now, we could draw in triangles. We have vertical angles, and then these lines are parallel because they intersect the chords in a specific way. Again, I'm not going through the entire proof right now, but because of angle, these triangles are similar. And then if you were to set up the proportion and cross multiply, that's where this ends up coming. If you would like to know more about the ins and outs of it, please let me know. But you just can understand that I'm telling you that they come from similar triangles. And when I say part times part, I mean the part of the same chord. So 23 times 41 equals 39 times x, because VU is what I am looking for. And then from there, it's just algebra. So 23 times 41 is 943 equals 39x. Divide by 39, and you get a fraction. And I believe it said round to the nearest tenth if necessary, so I'm going to change that fraction to a decimal really quick so that we can follow the rules. And when I round to the nearest tenth, I get 24, and it's 0.17. I don't care what else it says, so it's 24.2 as my final answer. Really quick note, we're not adding the arcs and dividing by 2 because we're not talking about angles in this scenario. We're talking about chords, which are lengths. So that's it for this one. Have a great day.